Hello, my name is Ramson. Today we are going to proceed with networking routers and routing protocols. This is part number 2. We are going to look about the routing protocols. If you missed the previous tutorial, which is part number 1, I have explained the networking routers. Please visit my YouTube channel for part number 1. So today we are going to look about routing protocols. Before we look about routing protocols, let's now remind ourselves about a wide area network. A wide area network is just a data communications network that operates beyond the geographical scope of a local area network. It connects devices that are separated by a broad geographical area than a local area network. One usually uses carriers such as phone companies, cable companies, network providers, as well as wide area network uses serial connections of various types. So wide area network is a combination or connection of local area networks. So there are several local area networks connected together. They form a wide area network. So computers on a given location are normally connected to a local area network. This facilitates information exchange and the administration. Always, wide area network refers to a network which covers a large geographical area and they use communication infrastructures to interconnect the local area networks. Examples of wide area network, we have military networks, we have government agents networks, we have airline reservation networks, and we have also large corporations such as banks, posters, and services. So let's now look about IP routing. IP is just a collection of protocols, not a single protocol. For instance, we have addressing protocols like IP version 6, IP version 4, but we have routing protocols which we have RIP, border gateway protocol, we have enhanced the interior gateway routing protocol. We have media access protocols such as carrier sensing multiple access with collision avoidance, collision detection, and so on. But let us see the roles performed by a router in the network, in the internet. So router perform different roles in the network. The first role, the router learn about different routes and destinations. Another route calculates the best path to destination. It also forward packets to outbound interface. But also routers store routing information. Internet routing protocols. A routing protocol specifies how routers communicate with each other, disseminate information that enable them to select routes between any two nodes on internet. A routing protocol must be turned on so that it can operate. Once turned on, some configurations are required. So if you want a certain routing protocol to operate or within a network, you are required to configure it. you have to configure that protocol so that it can operate on a specified network. We have categories of internet routing protocols. We have proprietary and open standard protocols. We have distance vector and a link state protocol. We have interior gateway and exterior gateway protocols. What does it mean by proprietary protocols? These operate only on a specific vendor devices and not for other vendors. For instance, we have this protocol known as Enhanced Interior Gateway Routing Protocol. This operates only for Cisco vendors, so cannot be used either by Huawei vendors and other vendors. So it only operates for Cisco routers. So such kind of protocol are known as proprietary protocols, but we have open standard protocols. This they can operate to any vendor product. For instance, we have OSPF, we have RIP version 1 and RIP version 2. But we have this distance vector protocol. They have the following characteristics. The first one, distance vector protocol, they are periodic updates. They give periodic updates, but also the knowledge about neighbors or broadcast updates. The entire routing table is included with a routing update. It involves hop counts. What is the disadvantage of distance routing protocol? There are several limitations or disadvantages for using distance routing protocol. The first one is the routing loops. Bandwidth consumption during route updates, slow convergence, waiting for periodic updates, partial picture of the network. But we have these link state routing protocols. These are commonly known as the shortest path first algorithms. These protocols use Dijkstra's SPF algorithms. Examples of these link state routing protocols are OSPF, ISIS. They are found on link state routing protocols. But we have several characteristics of these link state routing protocols. The first one is triggered updates. What does it mean by triggered updates? These updates, they are generated only if there is a network change. It doesn't wait for someone or admin to configure or to update. So this, they knowledge once upon there is a network change. So what this is different from the distance vector, which is periodic updates. The updates are periodic. So this is a little different with the link state routing protocols. But this link state, they are multicast updates. Multicast updates. The update is sent to a group of neighbors on knowledge of a complete view of the network. Only changes in the network are included in the update packets rather than the entire row. We have this interior gateway and exterior gateway protocols. Interior gateway, these are protocols that operate within the same autonomous systems as a network with a single administration or owner identified by autonomous system number. For instance, we have this RIP version 1, we have RIP version 2, OSPF, EIGRP. These are among of the protocols that operate within us autonomous system with a single administrator or single owner. But of these exterior gateway protocols, they operate for different autonomous systems. For instance, we have a border gateway protocol. It can operate within different autonomous systems. We have route types. Let's see the route types. Route types, we have several types of route. We have static routes, we have dynamic routes, as well as we have connected routes. Static route will operate when administrator configures all routes manually to all communicating devices. So the administrator has the task to configure all the routes that are connected to any device, to each device within a network. So such kind of routes is known as static routes, but we have dynamic routes. These are generated by routing protocols. Routers configured to run a specific routing protocol will be able to exchange route information or routing updates. So this doesn't need an administrator to configure the routes. The configuration is done by routing protocols. So we have connected routes. These are directly connected network to a router are automatically added to the routing table or routing source. We have this called routing metrics. What does it mean? Metrics are cost values used by routers to determine the best path to a destination network. The most common metric values are hop count. These are mostly used for distance routing protocols like RIP version 1, RIP version 2, and so on. But we have bandwidth is one among the metric that is used to determine the best path to a destination network. We have delay, reliability, load, and cost. We have something called administrative distance, known as AD. Administrative distance is just a measure of trustworthiness of a given route by a given routing protocol. So once a router receives several informations from different networks, so it uses administrative distance to measure the trustworthiness of a given route so that the router can forward that, that packet to a destination.